back to the README. Now we need to implement the actual triage step. So I'll paste this prompt in. The last one, after this, you're on your own. So here is what we are requesting. Implement triage step to filter articles for business relevance. First, create AI model factory in pipeline AI models.py that returns the appropriate Gemini model for each step. Triage uses Gemini 2.5 Flash Lite. So this class will help us use the most appropriate model for each step. It's kind of a nice way to encapsulate this all in one place rather than hard coding this in the individual step implementation. One thing I've experimented with some luck, is to actually make this environment dependent so that I can run it in dev using lower end models and then only use the higher end models in production. So I'll leave that as an exercise to you if that's something you're interested in. But most of the time, I just keep it consistent for all because, there is a fair amount of prompt engineering and things like that do apply to the model that you're using. You might need a little bit more of that if you're using a lower quality model and so on. All right, triage step should load articles that are pending triage decisions, process in batches of 40 articles. For each batch, call a Pydantic AI agent that returns structured triage decision-based objects, persist decisions to database. So that's kind of what I alluded to earlier, right? So Pydantic AI has this concept of agents that call LLMs, and they can define inputs and outputs, and the outputs can be expressed in terms of Pydantic models. So that takes care of all of the complicated validation and means that we don't have like a brittle JSON results that we have to parse and then deal with error handling when it actually didn't return quite the right structure or anything like that. It avoids that from ever happening. Important when sending articles to the LLM, map article UUIDs to simple sequential indices 0, 1, 2 and include that index in the prompt. The LLM returns decisions referencing these indices, which we map back to UUIDs before persisting. This avoids issues with LLMs truncating or mangling UUIDs. So this part is actually really important. So what this means, this is something that I bumped into early on when I was experimenting with using cheaper models like this for the triage step. And that's really important as well because we're processing so many inputs, right? Up to 1,000 articles or so. This can get really, really expensive if you're using the Gemini Pro model for all of that. And it's really not necessary. The cheap model is perfectly adequate at looking at a truncated article body and quickly assessing whether it's relevant or not. The one exception is initially I was passing in my article IDs, which are these long UUIDs, right? And I found that in the response, it sometimes got lazy, if you will, and truncated some of those UUIDs. And when I researched it, that turns out to be a pretty common problem with lower end models. So rather than giving up on the model altogether, what I did was simply work around this by mapping those to sequential IDs. So when we pass in a batch of articles, we'll just refer to those as 0, 1, 2, 3, and so on. And then when it responds, it'll include that number, so 0, 1, 2, 3. And then we'll just have to map it back to the UUID so we can identify the actual article in our database. So that works really efficiently and consistently. It's very robust. The agent's system prompt should define a news editor persona filtering for startup and business relevance. So here we give it some guidance about the actual prompt. So we're essentially asking an LLM, right, Claude, to do prompt engineering for another LLM, for Gemini. I find that kind of fascinating. Anyways, we'll take a look at the system prompt that it ultimately generates. Maybe it'll be fine right away. Maybe we'll have to do some mild prompt engineering, but this gives it some guidance of what to engineer there. And then finally, we're telling it to update the command line interface. So once more, we will kick this off. Okay, that was fairly quick, actually. Let's see what we have here. All 14 tests pass. We have the AI model factory that returns the appropriate Google model per step. Triage uses Gemini 2.5 Flash Lite. Extraction uses Gemini 2.5 Flash. Everything else defaults to Gemini 2.5 Pro. That is from the Claude.md, where I'm actually specifying the models to use for each step. So it kind of went ahead and did all of that. Then we have the triage step, where we fetch all the articles pending triage, do processing in groups of 40, like we asked for. It maps UUIDs to sequential indices, sends each batch to a Pydantic AI agent with a news editor persona, maps indices back to UUIDs. So this all looks good. And then we have indexed triage decision as an agent output model. Okay, we'll look at this in a second here. Overall, the shape of this looks pretty solid. So let's see. I closed the Claude window to the right. So we have enough real estate here in the IDE to see a side-by-side diff. So for the CLI, right, you see how it has a list of all the steps that it executes. So that's a really simple pattern. Here we have the AI models class. Yeah, that looks pretty solid. So it basically implemented a default model and then a way to override it on a per step basis. You pass in the step key, and if there is a model specified, it uses that. Otherwise, it defaults to the default. That looks very solid to me. And again, what I mentioned before, if you wanted to experiment with using lower end models in development or something like that, this is where you would change that. You could easily just have a separate step models dictionary for each environment, or you could introduce a notion of quality levels, low, medium, high, or something, and then for each level have a different set of Gemini models. So feel free to experiment with this at your own leisure. So then here's the actual step implementation. Up here is just all the imports. We had the fetch step that we implemented previously. Okay, I can see one thing that I might want to change. Let's look through this first. I actually opened up the file here without the side-by-side diff. Since there is no prior version, this is a little bit easier to see on the screen. So we have a constant here where it defines the triage system prompt. So let's read through this first, make sure this actually looks solid. You are a senior news editor at a startup-focused publication. Your job is to filter incoming news articles, keeping only those with clear relevance to startups, emerging business models, venture capital, market disruption, or technology commercialization. For each article you receive, identified by its index number, decide keep equals true. The article contains actionable business signals, market trends, funding news, or technology breakthroughs relevant to startup founders. Keep equals false. The article is off topic. For example, celebrity gossip, sports, general politics without economic implications, routine weather reports. Provide a brief reason, 1 to 2 sentences explaining your decision. You will receive articles as a numbered list. Return 1 decision per article, referencing articles by their index number. All right, that's a mouthful, but this is actually perfect. That's very, very similar to what I'm using in my pipeline. So more than enough details here. So let's see. It has some sort of helper classes that are defined here, right? So here's the actual step class, triage step, but it implemented a indexed triage decision. This is essentially similar to the, here, let's look at our models file, right? So here we have triage decision base, article ID, keep, and reason. And then we have the triage decision down here. So here in our steps, this looks very, very similar to our triage decision model. I think the reason it added this, and that seems completely reasonable, is that we're using this index-based approach. right? So our normal model uses UUIDs since it has an actual article ID. And then this one instead uses an index to reference the article. There are other ways to do this. So we could refactor this to try to force it to reuse the triage decision model, but that requires its own workarounds. So this is actually a reasonable approach. I'm going to keep this. The triage batch result, this is essentially what we're asking the agent to return, right? So it needs to return a list of these triage decisions, one for each article in the input. That's why it needed to introduce this batch result. That makes perfect sense. And then we have the actual triage step. So we have a key here of triage. Load inputs. This is where we use the new repository function that we added that loads all of the articles that are pending triage. And then process. Let's look at this real quick. Okay, so we are basically dividing it into batches of 40 in this case, but it's using a constant for that, which is perfect. So we can easily tweak things if needed. And then for each batch, it does this index to article mapping. So that's perfect as well. And then presumably it'll use this later to map things back. Then it added a private function here to format the batch prompt. Then we actually run the prompt, and then it's going through the outputs, and it's mapping the articles back to the original article based on this mapping dictionary. And then here, we now create the actual triage decision objects that use article IDs instead of indexes. Then it returns all of those. So that looks good to me. And then the base class, right? The pipeline step base class should be calling persist to actually store the results in the database. So that's where it'll use the triage decision repository to persist all of these outputs. So that actually looks good. We're getting some stats here. The number of articles that we triaged, how many were kept, how many were discarded. So that's perfect as well. And then down here, there's our helper function to create the batch prompt. Let's look at this real quick. So we got the dictionary. For each article, it basically appends the article index and then the article title. And then it's using the first 500 characters of the article body. That looks fine. We'll keep this as is for now. I've actually had good results with even truncating this to 300 because most of the time, the first paragraph or so of the article will give us enough of a sense of whether there's likely to be useful business signal in there or not. So we might actually tweak this later. All right, so overall, this actually looks like a pretty solid implementation. There are a few things that I'm not super happy with. So let's ask it to iterate on that a little bit. I'll type in the prompt and then I'll explain my reasoning. Okay, here we go. So again, I'm happy with the result overall, and we'll test this in just a second. But here are some things that I would do differently. So I'm going to ask Claude to do that. First off, I'm going to say, it looks like the user prompt only contains the article list, right? So if we look at this code here, it calls format batch prompt, which performs this mapping and then adds a line for each article. And then that ultimately becomes the prompt that we're passing into the agent here. There's no preamble. And that would probably work fine because the system prompt is actually fairly detailed. It has instructions on what to do with it. But I think it's best practice to still have a little bit more context in the user prompt as well. So I'm going to tell it, while the system prompt already contains a lot of context, I think it would be best to still add a short user prompt before the article list. For example, please triage this batch of articles, carriage return, and that's it. So that should work well. And then the second one, I don't really like how it kind of littered this steps class with all of these constants and kind of helper classes that are specific to the triage step. So my preference, and maybe this comes down to personal preferences. So again, it would work just fine, but I prefer to have all of this encapsulated within the step class. So I'm asking it to move it in there, right? So please move any constants and helper classes that are specific to the triage step, i.e. triage system prompt, index triage decision, triage batch result, into the triage step class. All code that's specific to a given class, to a given step, should be encapsulated within that step definition. Those are really my only gripes. Also note that in hindsight, I probably could have used plan mode here as well, and actually given it that comment in response to the plan before it even moved to the implementation. But, these are super simple things to fix afterwards as well, so no worries. All right, it's done. Let's take a look down here. Oh, I see. It probably updated the format batch prompt at the bottom. There we go. So it adds, please triage this batch of articles as the first line, and then appends the lines for the articles. That works. It moved the system prompt constant into the triage step, as well as these two helper classes. So those become inner classes now. So that looks good. Let's actually go ahead and shorten this here as well. All right, so I'll just ask it to truncate articles to 300 characters instead of 500 characters for the triage step. I know I'm being super, super lazy here. This would have been a trivial change to do myself. It's amazing how quickly you get used to having Claude do all the coding for you. For completeness sake, let's run the tests. That all looks good. I'm going to commit this, and then we're going to talk about how we can actually test this.